Hello everyone and welcome to this video on some basic systems of two equations. Now before we get into this, you're going to have a couple prerequisites. The first is you're going to have to know how to translate written problems to equations. So for example, let's say John has 3 times as many apples as Elliot, which is also 3 times as many as Becky's. So we can say J for John's apples equals 3 times how many Elliot has. We can say that equals how many Becky has plus 3 more. And for a second prerequisite, you're going to have to know how to manipulate basic algebraic equations. So for example, we have x times y plus 1 equals 2, and we need to solve for x. So we can subtract 1 from both sides to get xy equals 1, and then divide by y on both sides to get x equals 1 over y. Now if you're comfortable with both of these prerequisites, you should be good for the rest of the video. Let's first look at a motivating problem to ask what a system of equations are and why they're useful. So assume you have 200 feet of fencing built on the side of your house, shown in this drawing, in the shape of a rectangle. Now the area enclosed by the fencing must also be 3,750 square feet. What are the dimensions of the rectangle? Now let's translate this written problem into some equations. So if this length of the rectangle is x, and then these two sides here are y, we have 200 feet of fencing, then x plus 2y must equal 200. That's because we have the length of this side x plus the length of this side y plus the length of this side, which is also y. So we just have x plus 2y. And notice I'm not including this side because this is built on the side of the house. Now let's make a second equation to represent the area enclosed by the fencing. Now since this is a rectangle, we can simply just multiply the side lengths here and the side lengths here to get the area. So we just get x times y equals, and since it's 3,750 square feet, we can just write that that is what x times y is equal to. Now this right here is a system of equations. System of equations is just any number of equations that must be true at the same time. Now our question here at the end of this written problem is what are the dimensions of the rectangle? So basically what we're asking is what does x equal and what does y equal? So we're giving these two equations and they must hold at the same time, and then we're going to try and find what x and y must equal so that these are both true. Now that we have our system of two equations up here, there are 3 main methods of finding x and y. The first one is graphing, the second is substitution, and the third is elimination, and I'm going to go over them in that order. I'll be starting with graphing as I feel it's the easiest one of these methods, and all you need to do is graph or plot both of your equations and find the points at which they intersect, aka where they touch. The only problem with this is assuming you're able to graph the equations. I have now graphed both of these equations on this plot here, and this straight line is the equation x plus 2y equals 200, and this curved line is the equation xy equals 3750. Now we have 2 different points here where you can see they intersect. There's one right here and one here. This first point is at 50, 75. So an x value of 50 and a y value of 75. And the second point is at the point 150, 25. So x value of 150 and a y value of 25. So this implies that we have 2 solutions to our system of equations. And those are x equals 50 and y equals 75, or x equals 150 while y equals 25. Alright, let's now move on to substitution. This is perfect if you don't have a way to graph the 2 equations. So your first step is you're going to solve for x or y using one of the equations, and which one doesn't matter. Now by solve for, I don't mean solve or get a value for x or for y, just write x or y in terms of the other variable. So let's look at this first equation here, and I can solve for x by simply just subtracting 2y from both sides. So I can get x equals 200 minus 2y. I'm not trying to find a specific value of x or y, just rearranging the equation to just have x or y on one side. So our second step here is we're going to plug in the variable you solved for into the equation you didn't use. So since I used this equation, I'm going to plug in, and we found that x equals 200 minus 2y. We're going to plug that in for x into the equation we didn't use, which is x times y equals 3750. So if x equals 200 minus 2y and x times y equals this value, then 200 minus 2y times y must equal 3750. And that's because here for x, I just plugged in what we got here from the other equation. Now our third step is we can solve for x or y in the new equation we made, and there should only be one variable. So here, this new equation we made, we only have y in here, no x. So then you can solve for y and get a value for y from this equation. And for this equation, we'll get the values y equals 75 and y equals 25. The fourth step is we need to plug in the value found for x or y into either of the starting equations to find the missing variable. So we've solved that y equals 75 or 25. We can now just plug it in to one of the equations to find for x. So I can say here that x plus 2 times 75 equals 200, and x plus 2 times 25 equals 200. And then there, you can just solve for x in both of these cases, which you'll get x equals 50 and x equals 150. And notice you'll get these same values if instead I plugged in y for the bottom equation. So we had, say, x times 75 equals 3750 and x times 25 equals 3750. We get the same values here. Now it's very important here too that we match up the same values here. Since we have multiple solutions, one solution isn't 50 for x and 25 for y. We have to make sure we pair up the corresponding equations. So we'd have x equals 50 and y equals 75, or x equals 150 and y equals 25. And that's all you need to do for this substitution method. So our third method here, elimination, I would consider to be the most advanced, and this is used mainly for a system of linear equations only. And a linear equation is an equation of the form ax plus by equals c, where a, b, and c are just numbers. So say 2x minus y equals 3. That's a linear equation because we have 2. This minus y is just minus 1 times y, and that equals 3. Or we could say y equals 2x plus 1, because we could just rewrite this as negative 2x plus y equals 1. Notice I just subtracted 2x from both sides. So these are both linear equations. And up here, I've created an example of a system of a linear equation. So both of these up here are obviously linear equations. Our first step here to elimination, which this sounds a bit complicated, but it's to multiply either or both equations on both sides such that the coefficient of x or y in both equations are the same, or are the same but with different signs. So let's say, for example, we have the equations 2x plus y equals 1 and x plus 2y equals 2. We can multiply the bottom equation again on both sides by, say, 2 to get 2x plus 4y equals 4. And this still holds true because, again, we're doing the same thing to both sides. If we did it only to one side, so say if we had 2x plus 4y equals 2, that wouldn't be correct. We have to do it on both sides. So now that we multiplied this by 2 here, we can see that 2x, the coefficient for this term up here is 2, and the coefficient for the x term in the bottom equation is also 2. Or say we could have equations that once we multiplied, we had 3x minus y equals 2 and minus 2x plus y equals 1. And you can see the coefficient for the y terms in both equations are the same but just have different signs. For the first equation, the coefficient to y is just negative 1, And for the coefficient in the second equation for the y term is positive 1. Alright, for our second step, we want to add or subtract the equations from each other so that the x or y term cancel out. And this is why we want the coefficients for the x or y term in our previous step to be the same. So for this example, I'm going to use this equation over here. So we have 2x plus y equals 1 and 2x plus 4y equals 4. Now I'm going to subtract the bottom equation from the top equation, and that's because if you notice here, if you take 2x and then subtract 2x, you'll just get 0. So now we have no more x term and we would just have a y term to solve. So we have 0 and then we have positive y. Now we're not going to add 4y because again we're subtracting this whole equation. So we're going to have plus y minus 4y. And then remember we have to do all of this on the other side too. So now we have equals 1 minus 4. So we're left with the equation negative 3y equals negative 3. Now for our third and final step, we need to solve for the value of x or y and then plug it into one of the original equations to solve for the other variable's value. So we're going to use this equation we found up here, and we're going to divide both sides by, say, negative 3. So we'll get y on one side, and then the other will be negative 3 divided by negative 3, which is just 1. So now we know y equals 1. Now I can plug y equals 1 back into either one of these equations up here that we started with. So I'm going to use the top. So I'm going to say 2x plus y equals 1. And since we know y equals 1, we can say 2x plus 1 equals 1. We just plug in the value of y, which is 1, for y in this equation. And now we subtract 1 from both sides, so we get 2x equals 0, and therefore x also equals 0. So now we know our solution to this system of equations is x equals 0 and y equals 1. Now let's apply those steps to this example system of equations up here. Again, both of them are linear equations. So we have 3x plus 2y equals 50 and minus 6x minus y equals 20. So the first thing we want to do is we want either one of these coefficients, the number next to the y or to the x, on both equations to be the same or the same number but with opposite signs. So my first thought is to multiply this top equation by 2 so that we have 6x, and then on the bottom equation we'll have minus 6x. Alright, now after multiplying the top equation on both sides by 2, we get 6x, 2 times 3x equals 6x, 2y times 2 is plus 4y, and then again we have to do it on the other side of the equal, so 50 times 2 is 100, and then the bottom equation just stays the same. Now if you notice here, we have positive 6x on the top and minus 6x on the bottom. This is good, because now we can just add the equations so that we have 6x minus 6x, which will just cancel out. So let's do that. Okay, 6x plus minus 6x, 0. 4y plus negative y, that's going to be plus 3y. And 100 plus 20, because again, do it on the other side of the equal sign, is 120. So now we're just left with this equation, 3y equals 120. And notice since we don't have an x term, we can just solve for y now. So let's divide by 3 on both sides. So we'll get y equals 120 over 3, which is just 40. So we know y equals 40. So now our final step is we can take this and plug it into either one of our starting equations. So I'm going to do it on the bottom equation because that seems a bit simpler to me. Alright, so we have minus 6x minus y, but we know y is 40, so we can say minus 40 equals 20. Now we just need to solve for x. So add 40 to both sides. Those cancel out. We get minus 6x equals 60. And now just divide by negative 6 on both sides. So now we just get x equals negative 10. So now that we have y and x, we can say our final solution for the system of linear equations is x equals negative 10 and y equals 40. Now you can actually check this by plugging x and y into both of these equations, and they should hold. So if you plug in negative 10 for x up to here and 40 for y into here, you should get 50, and the same for this bottom equation as well. And that will be it for today's video. Thank you so much for watching.